So the growth and population of a city can be seen using the formula P of t, P for population, T for time, equals 11,235 e to the 0.008t, where t is the number of years since 1970. So 1970 equals 0. Okay? So according to this formula, how many years will it take for the population to double its 1970 value? Round to the nearest tenth of a year. So my equation is P of t equals 11,235 e to the 0.008 t. Okay, so what I'm looking for, be big, what I am looking for is this, because, all right, so if 1970 is 0, if we evaluate with t equals 0, that becomes e to the 0, and any number to the 0 power is 1. Okay, so my population in 1970 is 11,235 millions, billions, whatever it was. Okay, so I'm starting with 11,235. Well, I want to double that. Okay, so if I have, no, stop that, 11,235 times 2, that means I want to get 22,470. So I've got 22,470 equals 11,235 e to the 0.008t. All right, now I'm solving for t. Remember that e is a number. T is trapped up in my exponent, and that's the variable I want, so I have to go to log world. But this exponent is only attached to e. So get rid of the 11,235. So since it's joined by multiplication, I'm going to divide both sides by 11,235, and I'm going to get t, or 2 equals e to the 0.008t, and that should make sense, because if the population now is 100%, if I want to double it, it would be 200%. Okay, so if my population is represented by 1, doubling it would be represented by 2. Okay, so there's a little 1 sitting there. Now, I see e as a base, so I'm going to take the natural log of both sides, because that's going to allow me to drop that exponent out front as a coefficient. So drop him out. So I've got the natural log of 2 equals 0.008t times the natural log of e. And what do we know about the natural log of e? His base is e, his argument is e, and if the base and the argument match, it simplifies to 1. So that's a weird way to write a 1. Okay, so now what I have is 0.008 times t, so I'm going to divide both sides by 0.008. And I'm going to get the natural log of 2 over 0.008 will equal t. Okay, so I've got the natural log of 2, and then I'm going to divide that by 0.008, and I get 8664, and I'm supposed to round to the nearest year, so 87 years. So in 87 years, the population will double. Okay. Oh, look, there it is. I'm supposed to round to the nearest tenth, so it's 86.6. All right, how much time will be needed for 27,000 to grow to 31 something if deposited at 4% compounded quarterly? So I'm solving for time. I need to know how long this thing is going to take. So what is my equation? Is 1 plus r over n raised to the nt. And I'm going to go ahead and fill this out, and then I'll make it bigger. So 31, 35, 80. And I started with 27,000. 1 plus my rate is 4%. Compounding quarterly is going to be raised to the 14. All right, so I have a equals p times 1 plus r over n raised to the nt. So I want to achieve this. I start with this. My rate is 0.04, and I'm compounding quarterly, which means 4 times per year. And then I know that n is 4, but I'm trying to solve for t. Okay, n is 4, but I'm trying to solve for t. So I'm going to go ahead, since this exponent is attached to just the parentheses, I'm going to divide both sides by 27,000. So divide the left and the right by 27,000. And that's going to give me, and this is going to be ugly, 31,035 80 over 27,000 is going to equal, and now I'm going to do the stuff in parentheses. Okay, so 4 cents divided by 4 is a penny. 1 plus a penny is $1 and a penny. So I get 1.01 raised to the 4t. Okay, so now I need to get this t down. So he's trapped up in the exponent, so I need to go to log world. So I'm going to take the natural log of both sides. You can take the common log if you want to. So I've got 31,035.80 over 27,000. And that's going to equal 4t times the natural log of 101. So all I did was grab that 4t and drop it out front as a coefficient. Okay, so I have 4t natural log of 101. Okay, now what am I trying to solve for? I'm trying to solve for t. So this says 4 times t times the natural log. So I'm going to divide both sides by 4 times the natural log of 101. Goodness. All right, 1. All right, so this is what I'm dividing by. Now be very, very, very careful. Any number divided by itself is 1. Any number divided by itself is 1. So what I'm going to do is I'm going to do the natural log part first. In the numerator, so I have the natural log of this big scary fraction, which is 31,035.80. Okay, divided by, so I'm still in the natural log, divided by 27,000. Close that set of parentheses and hit enter. So my numerator, this portion, is 0.139 something or another, divided by, in parentheses, 4 times the natural log of 101. So divided by, in parentheses, 4 times the natural log of 101. Okay? And that gives me 3.499999. So basically 3.5 years. So it should be about 3.5 years. All right, minimize u. So it says round to the nearest tenth is 3.5 years. Okay. All right, a sample of 450 grams of radioactive substance decays according to the following function. So I have, all right, a sample of 450 grams of radioactive substance decays according to the function A of t equals 450 times e to the negative 0.048t, where t is time in years. How much of the substance will be left in the sample after 20 years? So they're telling us that t is 20. So when, ooh, what have I done? All right, so when we look at this, they tell me that t is 20. Remember that e is not a variable, e is a number. So I can actually just enter this thing straight into my calculator. So remember, put your exponent in parentheses. So I have e to the, and then I'm going to put negative 0.048 times 20, and I need that times 20 to be in the parentheses as well. Okay, so that tells me from e over, now I just got to multiply by 450. So times 450 gives me 172.30. So I should have 172.3 grams left in my sample after 30 years. Okay, so what do I have? 172. There it is, right there. All right, I'm trying to get this all in last video. All right, use the specified row transformation to change the matrix. So I have a matrix of, hang on, I have a matrix of 2, 4, 6, 5. So 2, 4, 6, 5, and I'm supposed to do negative 3 times row 1. So negative 3 times row 1 added to row 2, and they already filled part of it in for me. They're already telling you don't touch the top row. Okay, so what I have is, make big, is this mess right here. I need to know what these two numbers are. So what I say is take negative 3 times row 1. So negative 3 times 2 is negative 6. Negative 3 times 4 is negative 12. So I took negative 3 times row 1. Now add it to row 2. That's supposed to be in row 2. So add it to row 2. So here's a 6 and here's a 5. Add these together and put your answer here. So negative 6 plus 6 is 0. Negative 12 plus 5 is negative 7. Okay? So just do what it says, but this part you're supposed to be doing in your head. All right. We have, make small. Okay, so we have, write an augmented matrix for the following system of equations and then give it size. So I have a system that is 7x, negative 7x, plus 7y is 8, and 4x minus 4y is 3. So my augmented matrix, meaning augmented means the answers are included, okay? And that's what this is for. That means equals. So just write the coefficients. Make sure you've got an x column, a y column, equals your constants. So this is a negative 7, 7, 8, 4, negative 4, and 3. So I just killed off the x's and killed off the y's. Okay. What is the size? How tall is it? It's 2 tall. By how wide is it? It's 3 wide. So tell me how many rows by how many columns. It is 2 rows. It is 3 columns. Okay. So now we know him. Close down. All right. Use Gauss-Jordan method to solve the system of equations. So I'm going to use either substitution or elimination. And I'm betting it's going to be substitution. So what I have is my system is negative 25x minus 3y plus 116 equals 0. And then I've got a 10x plus y minus 47 is also 0. So the first thing I'm going to do is I'm going to move my constants to the other side so that I've got an x column, a y column equals my answers. So I'm going to subtract 116 and I'm going to add 47 and I'm going to rewrite. So what I have now is a negative 25x minus 3y's is a negative 116. What I have on the bottom row is 10x's plus a y is positive 47. Okay, so I'm looking, it's going to be easier to kill off my y's. Okay, so I'm going to multiply that bottom row by 3 because negative 3y's plus 3y's is no y's. So I'm going to take this and say 3 times row 2, and that simply helps me track what I'm doing. Okay, so now what I've got is a negative 25x minus 3y is a negative 116, and then 30x's, would help if I would multiply, plus 3y's is 47 times 3 is, I don't know what that is, 141. Okay, and now I can work vertically. So 30x's minus 25x's is 5x's. Negative 3y's and 3y's is no y's, and 141 minus 116 gives me 25. So divide both sides by 5. So x must be 5. X must be 5. So now that I know what x is, go back into one of your original equations and figure out what y is. I think this is the easier one to manhandle, so that's the one I'm going to choose. So I've got a 10x plus a y is 47. So 10 times 5 plus y is 47. 50 plus y is 47. So I get y equals negative 3. So you have a single solution. Order matters, okay? Your solution is x is 5 and y is negative 3. So that's where those two lines cross. And I'm not going to make it for the last video. We might. Yeah, we will. All right, here we go. All right, use Gauss-Jordan to solve the system of equations. So this is just going to be a slightly longer video. All right, so again, I got 2x minus 7y. And that equals 3. And 4x minus 14y is going to be 2. Okay, so I'm going to go ahead and use elimination. So if we kill our x's, if this was a -4, I could add it to 4 and it would zero out. So how do I change a 2 into a -4? I multiply row 1 by -2. So that gives me -4x's positive 14y's equals -6. This bottom row didn't change. And now I start adding. So how many x's do I have? None. How many y's do I have? None. So I have 0 equals -4. Is that possible? No. Okay, that's impossible, which means these are parallel lines. So if we are trying to find the answer, which would be consistent, then we have nothing. Nothing's going to work. Nothing at all. And that is it for your final exam review.